So in my previous video I showed you how to draw this structural equation model. We went through the process of drawing this structural equation model, whereby we have 3 independent variables and 1 dependent variables. So in this video I'm going to take you through the whole process of running the analysis, how to run this analysis, how to run this structural equation model analysis. So the first thing that we need to understand is that we need to understand these variables. We have 4 variables here, 4 latent variables, each of which are measured by the observed variable. Remember in my previous video I explained to you the differences between the latent and the observed variables. So in this video I'm going to show you how to run this model. So the first thing that we should know is the variables that we have. We need to know the variables. So we have the independent variables and then we have the dependent variables. So we have 3 independent variables: the AI training, which is this one. Then we have weekly training plan, which is this one, WT. And then we have the physical training, which is this one. So these are the independent variables. Then we have the dependent, which is technical skills acquisition, which is our TS here, the technical skills acquisition. So we are measuring how does these 3 affect technical skills acquisition. In other words, how does AI training, how does weekly training plan, and how does physical training affect technical skills acquisition. So having understand the variables, then we can look at the objectives. So we set objectives for each of these relationships: the relationship between AI and TS, WT and TS, and PT and TS. So we develop a relationship, we develop objectives for each of these relationships. So for the first objective is to determine the effect of AI training, this one, on technical skills acquisition, and to find out the effect of weekly training plan on technical skills acquisition, and then to investigate the effect of physical training on technical skills acquisition. So in other words, we are trying to find out how does each of these independent variables affect the dependent variables. Then from that means how this relationship, how does AI affect relationship, affect TS, how does WT affect TS, how does PT affect TS. That is why we have this arrow. It is moving from AI to TS, the effect of AI on TS. The arrow is moving from WT to TS, the effect of WT to TS. And this arrow is moving from PT to TS. Remember, the direction of the arrow shows the direction of the effect. Okay. Then from each of these objectives, we develop the hypothesis. One thing you should note is that hypotheses are developed from the review of the literature. Having developed the objectives, then you go and review the literature, and from what you find in the literature, you develop the hypothesis. So in our hypothesis, we say that AI training has a positive and a significant influence on technical skills acquisition. Weekly training plan has a positive and significant influence on technical skills acquisition, and physical training has a positive and significant influence on technical skills acquisition. It means each of these independent variables has a positive and significant effect on TS. That is what we hypothesize. That is what the literature review tells us, meaning that each of these positively affects physical training, physical training skills acquisition. Okay, so having set the hypothesis, the next thing is to run the analysis. So now we come here, you can see that this icon here is not active, so we cannot be able to see the results. So we need to run this model so that now we can be able to see the results. So the first thing is to import the data. In my previous video, in this series, I showed you how to import the data into AMOS. So you click on this file, takes you to your computer. You click on the data that you want to use, then you import it to this window, then you click OK. Having imported the data, then you click on this window which says analysis properties. When you click, a new window pops up. So now I had already selected the output I want. So this window, if you click on this estimation, there are different estimations you can carry out. You can carry out maximum likelihood, generalized least square, and weighted least square, scale free least square, or asymmetric distribution free. But we stick with the maximum likelihood estimation. Then you go to output. So these are all the outputs that AMOS can produce, all these. But for this model, we stick with the maximum minimization history, and also we stick with standardized estimates. We also stick with the squared multiple correlations. Then we select the indirect, direct, and total effects. We need to see the direct, indirect, direct, and total effects. Then we go to total scores, factor score weights. Then we go to the covariance of estimates, and we also check the correlations of estimates. So these are the results we need for now. Maybe in a later video I will show you what it means on the other output. So having selected what we need, the output we need, then we close that window, and then we click on this icon here. So this one, it says calculate estimates. So we click on it, and then the model will start to run. So you can ignore this message which says AMOS will require the following pairs of variables to be uncorrelated. So you just ignore that one and click proceed with the analysis, and then AMOS will start run. You can see at the end, at the right corner, the analysis is running. Once the analysis is completed, then this icon here, you can see it has changed to green. Then you can click. When you click on this, you can see the results has appeared. You can see if you click on the left one, the results disappear. When you click on the right one, now you can be able to see the results. Yeah. So we have two types of results. We have the unstandardized estimates, and we have the standardized estimates. So if you click standardized estimates, you can note that there is slight changes in the factor weights. So these lines, these values you see here in this arrow, in this line, these are the factor weights. So these factor weights or what we call the factor estimates, they be either unstandardized. So you can see they are changing. These are the unstandardized one, or they can be standardized. They can be unstandardized, or they can be standardized. So now to see the results, we click on this icon here. It says view text. When you click on it, the output now will appear. The output will appear. So that is the output for that model. So there are different output that we may need to check. The first thing is the notes for the model. If you see, click here, notes for the model, you get these results. It gives you the chi-square result, it gives you the degrees of freedom, and it also gives you the probability level. And another thing that we may need to, you can click here on the estimate to expand it. Click there, then you click on scales, you expand. Then you click on regression weights. So this is the regression weights. What we are particularly interested in is this regression weights here. This regression weights. So this regression weights is the first three: the movement from AI to TS, WT to TS, PT to TS. These three. Let me highlight for you here. That one. These are the major ones that we are interested in. So what you should remember is that to get the results, we check the regression weights. You click on the regression weights, then you get the results here. Then you can see the effects of the independent variables on the dependent variable. You can also check the standardized regression weights here, these ones. But what we are interested in is the regression weights, which gives the standard errors. It gives the CI. It gives also the p values. So I have copied the three and put them on a Word file. Here it is. You can see this one is 0.373. If you come here, you can see that this one is 0.373. This one is 0.128. So this one is also 0.128. So I want to explain how we interpret these results. So you can see this one was our hypothesis 1. This one, AI has positive and significant effect on technical skills acquisition. So hypothesis 1, effect of AI on TS, effect of WT on TS, effect of weekly training plan on the technical skills acquisition, and the third hypothesis was the effect of PT, physical training, on TS, technical skills acquisition. So these are the regression weights, or what we call the beta weights. So you can see in this beta weight here for the first hypothesis, it is 0.373, and it is positive because it is not negative, it is positive. So if the standard error is 0.058, but if we check the p-value, the p-value is it has 3 stars. This 3 stars means it is significant at 0.01 significance level, at 99% confidence level. Then so I have explained it here. You can see that AI training has a positive because this one is positive, and significant because the p-value is less than 0.01, influence on technical skills acquisition because you can see here our beta is 0.373, and our p-value is less than 0.05 at 95% confidence level. So then we go to hypothesis 2, this one. So this is our hypothesis 2. This is where I have written the results. So we are saying weekly training plan has a positive because this value here is positive. You can see this value here is positive 0.128, and significant because this p-value here is less than 0.05. So you can say weekly training has a positive and significant influence on technical skills acquisition. Then you put into bracket that beta is equals to 1.28, and p-value is less than 0.05. Then you go to the last one. The last one is physical training. Sorry, this one should be physical training. So physical training has a positive and significant influence on technical skills. So it has a positive. This 0.814 is positive, and it is also significant because the p-value is less than 0.05. So physical training has a positive and significant influence on technical skills acquisition. So we put into bracket that the beta is positive, so 0.184, and p-value is less than 0.05. So now that's how we run and interpret the results for the structural equation model.